Share slides. Okay. Oops, sorry. It's IETF 112. You can catch the chair who copies and pastes the slides from last meeting. That's me, not Job. I'm Chris. The other guy is Job, or Yob, if you prefer. This is IETF 112. We're somewhere in the EU time zone. I think we're supposed to be in Madrid. Here's the note well. Everyone knows where to find this. You should read this eye chart. It's probably not an eye chart on your computer, so you could read it. All of our resources are available. Also, it also wherever it says 111, it should say 112. Boy, I'm going to hear about this later. All the slides should be updated on the meeting materials page. Fortunately, Medico has a little quick link for that, which is super nice. Thanks to the Medico folks. Blue sheets, we don't have to do anymore. That's taken care of in the Medico thing. We do need a minutes taker. So if someone wants to volunteer to take minutes, that would be terrific. That probably didn't make the display any better, did it? All right. I can't tell if it makes it any better or not. Anyway, so until somebody speaks up and says, I'll do the minutes, we're going to wait. The Jabber scribe is the Jabber room, which automatically gets caught up for us, or is the in Medico chat, I mean. Oh. I think Mr. Hollyman is telling me, Joel will do the minutes. Terrific. He's a great minutes taker. Mike Hollyman perhaps has a link that will tell us how to use the share slides for next time. Agenda bashing, charter update. Oh, no charter update this time, sorry. Here's our agenda. We have some TLB stuff for BMP from Paolo, an update to his document, 5 or 10 minutes worth of chat time. And then Edward has an on-host load balancing for telemetry conversation to have, some research work, I believe he and Thomas did in the hackathon, I think. I could be mistaken about the hackathon part. Please feel free to correct me, Edward, when you get up. I think at this point, we're not finished. It's time for Paolo. So unless there's any questions we want to get out of the way first, give people a couple minutes while I find the slide deck. Or Paolo, you can do the slide deck yourself if you prefer. Just do the screen sharing thing and we'll.
Oh, I prefer if you can share the deck that I sent, just because I have troubles sharing my screen with Miteco.
Yeah, no problem.
And share screen, some video, so that you can look at me as well.
Okay, give me a second to go get the right set of slides going.
Sure.
Share screen. Click on the 16 things.
And hopefully I did the copy paste better than you guys.
Maybe. I mean, it's honestly going to be easy to do that better than me, for sure. All right. Let me. Also, I suck at webbing. My son tells me all the time. All right. Anyway.
Okay. So yeah, I can start. 5 minutes about TLVs for route monitoring and peer down messages. It's just a very quick update. So if you can go to the next slide already. Very short recap. What the draft is doing is that not every BMP message does support the TLVs, and so essentially, namely the route monitoring and the peer down. So we wanted to add that support, and in order to do that, we are bumping the version to version number 4. Next slide, please. Still as a recap. So as you will see, it's 2 slides of recap and 1 slide of content. So we have generic and indexed TLVs. So generic TLVs is just the TLV of all your life. Doesn't need to have any explanation. Whereas the indexed TLV is the TLV, but you have also that one index field after the length. Okay, so why the indexed TLV is needed? In the end, it is needed for route monitoring messages, right? So we took a kind of a scenic route on saying, what do we do if we have a TLV in route monitoring message, whether we want to address the whole, all the NLRIs that we find in the BGP message encoded, in the route monitoring message, or whether we want to address just one specific or, NLRI, right? So the index comes from that need. So next slide. And essentially, so what we did, and that's the only change that it's in revision number 6, is that if the index is 0, then it means that the TLV does apply to the whole BGP message, or otherwise, if it's a positive number, then it applies to a specific NLRI. So very simple in concept, I would say. This is the only change that we did, and I think that was the only outstanding, piece of work that really needed to be done. I don't know if anybody has some feedback. I mean, I anticipated this change already in the previous IETF meeting, so we had a couple of options, and this kind of looked the most natural for us authors, and also I received some feedback, and it seemed, kind of consensus to go down this way. I don't know if there is any feedback, from anybody in the audience. Otherwise, if not, I would say for the chairs, this seems to be a kind of done work, and maybe we can last call it or something like that and move forward. Thank you.
Thank you. I think if you are asking for working group last call, you should definitely make a comment on the mailing list so people
Sure.
that aren't here can speak up. I mean, as a standard, chairs always say this thing.
Fantastic. We'll do that after this.
Okay. Other than that, thanks for the presentation. And
thank you. Thank you.
If no one else has put their hand up to say anything, so I think definitely put your message for work. Please make a work group last call for this. Now.
Fantastic. We'll do that. Thank you. Thank you very much,
Thanks.
guys.
Edward, do you want to run your own slides, or do you want me to, or somebody else to run them for you?
I think I'll try it on my own. We'll see how it goes.
Okay.
Unfortunately, the test room from Meetaco was down, so let's see how this goes.
All right.
All right.
Your audio is perfect.
Yeah.
Let's see. Screen requested. Granted. Yes. Yes. And okay. It looks to me like you all should be seeing it. It's just a lame title slide. Is that, can anyone see it?
Looks great, yes.
Okay, awesome. In that case, let me get started. So the context of, so this is compared to the previous stuff, this is a bit more academic work. The context was a master's thesis in this case. Thomas was so kind as to supervise the whole thing, and Pierre also on this call was also providing tons of help. So thanks to them upfront. So let me get started then. The context for this whole thing is the notion of device telemetry, right? And what we want is to understand the networks, we want to combine different perspectives from basically combine information from various angles. So specifically, we might want to extract information about whether a certain flow belongs to like a specific VPN by combining control plane and forwarding plane information. And the way we obtain that information in the first place is via like network telemetry protocols. And these can be various things, right? It can be BMP for for BGP type information, right? IPFix for flow information, or like YANG push for device level stuff. So to collect that information at all, we need to basically make sure that it gets routed to the right place from across the network. So ideally, we just define a single globally unique endpoint and just route anything there. Luckily, that also allows us to use Anycast for the regionalization part. We can just ECMP balance across there, and finally, once the traffic actually hits our machine, VM, whatever, this is where things become interesting, and we actually need to balance among different processes. And the challenge here is primarily from a administrative and like local performance perspective, right? Because getting it to work somehow is easy enough. It's more like in terms of making it work efficiently. So in the context of this work, you have to imagine we have like a network with routers pushing information to like some sort of host. The main interesting part here is that to combine the information, to combine the different perspectives on that target host, we need to make sure that all these different perspectives from the same device arrive at the same endpoint, right? Because otherwise we just don't have the data streams to combine them early. We could eventually, we could of course like globally tag everything and then throw everything in like some data lake type setup and then just do matching there. But that is, first of all, it is expensive. It is late in the process and prone to failure at that level. So for this case, we can just imagine the setup where we have these routers and they just push BMP and IPFix information. The collector that we used here was PMA CCT's NFFD, thanks to Paolo for creating these. So and later on, you can imagine this is then used then for some sort of like OLAP querying where you want to like find out information about your network, but that's out of scope here. So if you look at as a baseline, we can just simply look at something really simple where we combine that data by introducing a layer of indirection, right? We have like N telemetry daemons that are collecting all that information, but to make sure that the right streams are ending at the right daemons, we put some proxies in front of them where all they do is basically forward the traffic. And in this case, we can just use something like HA proxy for the TCP part, and NFFD itself can actually act as a UDP proxy, and we can use that for IPFix, right? Like a relatively simple setup. The main challenges in this type of setup is the mapping, right? Because we need to in fact make sure that stuff ends up at the right target, the file in the little box in the middle in this case. The challenges here are relatively straightforward, I think. It's the reliability of having additional components that may fail at any time, right? They suffer through update cycles, they suffer through process lifetime cycles, all of that stuff. There is overhead, right? You have proxies that you don't strictly need in that sense. You have latency impact, which you probably don't care about so much, but in general, just limits to what we can do here. And the main administrative challenge is the configuration overhead, because we need to, it's basically these files, right? We need to configure two different proxies with different configuration syntaxes to support like all of these devices sending across multiple telemetry protocols. In my example, only two, but can be any of them, right? To then find eventually any, to correctly balance it across the different backends. And this is what we want to solve. So what can we do? So there is a socket option, just as a refresher, there's a socket option called as a reuse port. And that allows us to basically statelessly load balance among a bunch of different processes. That's super convenient, but unfortunately the problem with that approach is that by default it takes, or in its standard configuration, it takes the hash of the whole flow. which means that different telemetry protocols will most likely end up at different daemons, telemetry collection daemons. So you're breaking the link, which is the whole purpose of doing this, right? You want to correlate these two different data streams. So luckily, this is something we can influence using BPF. Specifically, there is a program called I think it's just called the reuse port that we can attach to help us influence the selection. As a refresher, BPF, right, is the subsystem that basically allows us to attach logic to custom predefined hooks. And one of these hooks is specifically the socket selection in the SO reuse port mechanism. So using BPF, we can basically just patch the collectors minimally to register themselves on some sort of lookup table, where they basically say, I am collector number 1 out of n, and I will receive 1/n of the traffic. This is the communication there. And then we can simply, using BPF, choose our own port selection mechanism, in which case we can simply, again, hash the flow, except that in this case, the only thing we need to look at is the IP source address, under the assumption being that we only have that all the telemetry is coming from a single interface that has like only a single IP address. And the second step is that we no longer balance across all the listening daemons, but across the intended number, which also means that we don't need to dynamically reallocate or try to solve the problem of reallocating established TCP connections across multiple daemons when some of them are going from some sort of like update cycle. Like imagine some sort of, like you have 10 of them listening, right? And then you have like a rolling update where you restart one after the other with some new binary version. And then you basically have chaos going back and forth. But if you just say that we always intend to have 10 of these, and we simply respond with a TCP reset or just simply drop the UDP datagram, if something doesn't happen to be listening in that moment, we have basically solved the problem. So we just can package up this logic into a little program and attach it to the reuse port group. And in practice, we'll just have the first daemon that starts up do this. And we can use the existence of the BPF program as the basically indicator that it exists at all. Using this approach, we basically now have stateless balancing, right? We don't need we don't need to deal with config files because they don't exist in that sense. Well, I mean, we still need to, of course, know how many we intend to have, but that is basically it. It's based on device identity only. Again, the link here being something like that the IP address corresponds, like a single IP address corresponds to a single device. If that wasn't the case, we could also do more complicated stuff. You can just parse the SKB from within that program. That is possible. It's stable across restarts in the sense that we are not throwing connections back and forth. We prevent a scenario of cascading failures. So imagine like a packet of death scenario that exploits this collector. If you simply load balance across everything that is listening at this point, basically every time this connection is tries to get itself reestablished, or the UDP packet gets resent in the IP fix case, you would basically like do a round robin of like killing these daemons. This way, you only have like a single victim that basically stays down. And doing it this way basically requires no configuration, right? It's just this one piece of information about how many you're going to have. So we have this. So to summarize what we've seen here, right? So we say that network telemetry aggregation, meaning combining different streams, we have additional requirements on load balancing that we wouldn't usually have by simply having the need to combine the streams from different across different transport protocols and transport protocol ports down to the same process, having to balance it this way. So we can solve this problem relatively straightforwardly using eBPF without using additional daemons on the system side. This is this is a pretty nice property, right? Because that means no vulnerabilities at that level, no upgrade cycles, no I misread the configuration or incompatible configuration updates. With BPF compile once run everywhere functionality that libbpf provides, you can basically, it's portable enough in that sense. We can balance stuff across an arbitrary number of endpoints because scaling up and down is relatively easy in this type of setup. This basically allows us to do the proper networking by always having this data correctly correlated instead of split across multiple data collectors and then having to aggregate it at a later stage. And it's much easier to maintain. And as a bonus, actually, if you try to benchmark it by doing like by running a BNB load generator in terms of connections, we're behaving much better. I think we're saving around like 20% CPU time by doing it this way, and the ramp up is actually feasible. Like if you run the load generator against like HA proxy, I basically have to slow it down before things just crash. Whereas in the kernel level balancing case, that is not a problem at all. And that's basically already it. The slot ended up being much larger than anticipated, so I guess that means we have plenty of time for questions this time. And if you want to read the same stuff in the form of like a thesis with like huge appendix and 70 pages, blah, 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 feel free to visit the link. So that's it for the scheduled items of my talk. I'm happy to answer any questions at this point.
All right. Ideally, if anybody has questions, they'll speak up. Yep.
Edward, thank you so much for this presentation. This is Edward's first IETF, so I think you did a fantastic job on sharing your insights with our community.
Yeah, it was a great presentation.
All right. Well, given that there doesn't seem to be anything on the chat, nor is anyone raising hands or interrupting, in that case, thanks everyone. Was awesome presenting, and special thanks again to Thomas, Pierre, and Paolo.
All right, I think that's the end of our presentations for the meeting. And unless anybody else has other things to talk about, going once, going twice. Anything you want to cover, Joop?
I want to go back to upgrading RPKI validators.
Okay.
All right, I think this was it. Thank you, everybody, and we'll see you at IETF113.
Bye-bye. Thanks.